Yo, what's up, what's up, what's up, what's up? Welcome back. Today we're working on my to-do file system. So the idea is that I have document storage, and I have stuff that has like two-way links or maybe complex links, right? So I have like maybe some task that I have a document for, and it's like, I want to look at like image to neural network color. And it's like part of the like image to text project. And so like I have that link, but it's also like, related to like black and white. And so like this is related. And this is also part of the image to text project. And this relationship here is like kind of different than this relationship here. And these are like two-way links. So if I say like I want to do black and white before I look at color, then black and white blocks color, color is blocked by black and white. And so I have these like multiple links between like different concepts, and I want to like store those somehow. So, you could be like, why don't you just like maintain symlinks between directories, and then you can like easily navigate between them. But I didn't like the idea of trying to maintain all of these links, and so we store links of between items in a database, and then we can kind of like navigate them that way. So we can say like, hey, I'm part of the image to text project, and like, what are my children? Here are the things that I'm working on. And if I wanted to look at like making a web UI, that's blocked by WASM, which is blocked by Rust. And then I can go back and see like, oh, what does the Rust block? Rust blocks these two things, right? So that's kind of like the pitch for the file system. And today what I want to work on is making it slightly more usable. So at the end of last stream, I was like, I'm not really sure if there's anything really more interesting to do on this. It felt like we were like pretty much there. We added this like interface to create items and stuff like that. But when I actually tried to start using it, it sucked. One, it crashes in some cases. Two, there's no real way to interface with like the relationships idea. So we have like, projects, we have like the image to text project, and he has children. And so I'm like, if I wanted to create a ticket and like maintain that relationship, be like, I want to create a ticket and I want to add it as a child to image to text, that's not really easy to do right now, because one, it's really hard for me to like go from the title image to text back to like, well, what item is this? There's like a list of numbers, but it's like really hard to tie those two things together. As well as like this like child relationship, like how do I identify that? As well as like how do I create one? There's like a lot of like unknowns here still, so I think we need to try to like figure out how to make it a little more usable. And so what I'm thinking is, first I want to like fix some of the crashes we're seeing. I think that there's a really easy way to reproduce one. If I just like navigate to that directory in my file browser, it's like, boom, explode. Another one is I want to like add like metadata to the file. So if I, hold on, let's remount it. So I want to be able to go into these tickets, items, whatever you want to call them, documents, and I want to be able to see like what's the name of this fucking thing and what is its ID, because like sometimes we're navigating by name and sometimes we're navigating by ID. We always want to tie it back to ID. I want to add a way to like see relationships. So maybe at the top level here, there's going to be like a relationships directory, and it's going to look similar to the items directory where it has like lists of IDs, and each one is going to show like maybe its pairing of names, like parents, children, blocked by, stuff like that. And then if we need to add a way to like manipulate those things as well. So we'll see how far we get today. I think that a lot of these things should be quick fixes, but I'm not really sure, so I guess we'll find out. What is this selection UI? This is called Ranger. It's this file browser I found way back. Ranger File Manager. Ford Ranger. That's not what I mean. Ranger File Manager. Yeah, it's this guy. And I just have it bound to a button that basically I navigate through with this thing, and then I hit Q, and then I like change directory in that directory. It's pretty sick. I use it a lot. Did you have to work with Jira in one of your past jobs, the frustration made you create your own? Well, it's more that like, I was like, I have a problem for myself, and do I want to use Jira to solve it? And the answer is no. It's not like an effective way to solve what I want to solve, right? So Jira has like a lot of features, and it's slow and bloated, which is like fair because they're trying to make like a solution for everyone, right? Their goal is to like sell to as many fucking big companies a ticket tracker, which means they have to support like every single use case. And one of those use cases isn't even what I want, right? Which is like, I just want to edit fucking files on my disk. So I think that like this is one of those things where I was like, I should be able to bang something out in a day or two that's like solves what I want. And it's like much way longer than a day or two, but it is one of those things where it's just like I think it's better for me to do it myself. Also, it's content, you know, gives me something to do. Okay, I think let's start with trying to fix one of the many. I think there's only like one source of crashes, but we'll see. So let's see if we can like fix it. So if I navigate here, we get like an insta crash. And it's like a panic somewhere in what looks like to be SQLite code. And it's saying, let's see, already mutably borrowed bar error. So my guess here, I haven't actually looked at this, but I'm fairly confident that the way that we're doing our bindings right now is we have this like, we call into libfuse and we say, here are all the operations we provide. And he calls us with like how do I say this? We feed in our like state. So we take our client structure and we pass it in as like user data to Fuse. And then Fuse has this call called get context. And I kind of just assumed that since this thing returned a immutable pointer, that meant it was like thread safe. But that's like a stupid assumption because, you know, C, things are just mutable by default. So I think what's happening here is that these things are getting called twice at once. I am casting my like mutable pointer back multiple times. And then we're getting into like the SQLite stuff. And he's saying like, hey, I expect to be the only person who's ever fucking accessing this. And that's just not true. I believe. So I think that probably what we have to do is we probably need to protect this in some way. Probably a mutex is reasonable. Probably. So we can do something like, what is it? Sync mutex. Pull in a mutex. When we call get client, I wonder if we can get away with returning a mutex guard here. So maybe we say something like, well, first when we make this thing, we should mutex lock him, protect him. So we can drop this guy in a mutex here, like this. And then here we are going to say this is a mutex, this thing. Okay. And then when we get the client now, we should be able to just say, so first of all, if we call this right now, I bet it would crash because we are getting this like void pointer from C land, and then we're just like assuming it's a Fuse client, and now it's not. It's a mutex Fuse client. So I bet some fucked shit will happen if we try to actually use this right now. Hold on. So we can let ls test mount, and yeah, immediately that crashes because we're just things like aren't what we expect, which makes sense. So we can go in here. And we can, let's make this a lot bigger, but keep the bottom one open. Here, we want to say that this is now a mutable, this is going to be an immutable reference to a mutex Fuse client. Okay, and then we can say client, how do we say this? Star client lock unwrap. And that returns, that should return something. What is this guy? He returns a lock mutex guard T. Okay, so we can say that this is a mutex guard, which has a lifetime of static because this thing from the perspective of our Rust code, he's getting a pointer that lives like from his mind for fucking ever. And so I think that we can just like wrap the whole thing in mutex, boom. And then what? Then we say this is a Fuse client. We need to use mutex guard here probably. Okay. And we spelled mutex guard here. Okay. And then I think we're probably chilling most of these places. I think we just have to write mute in a bunch of spots now. mute, 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 mute. All right, I think that's all of them. So hopefully now that same crash that we were seeing before when we went to here, that's a good sign that it's no longer crashing. That one was like 100% repo before. And it looks like we're chilling now. So easy peasy. Is it not possible to make each function safe, or is it because of the external depths? Okay, so the reason that each of these, if you're talking about these guys, well, not that one, but most of these guys are unsafe because if you look at the bindings, we are like feeding function pointers essentially to Fuse, and he is like a C API. So the function pointers that Fuse is expecting in Rust have the signature unsafe extern C function, and so I think I have to say that it's unsafe as well here. Now, could I try to like wrap these things and call safe functions in between? Like, yeah, the only unsafe you really need is like this pointer cast, probably. I guess also we're calling out to like some like proper C functions as well. But yeah, I could scope it a lot more, but also I just like don't really care. What language is this? This is Rust. This is Rust. The internet loves Rust. Maybe less now than they did a few years ago, but yeah, the internet loves Rust. I like it, but there's also a lot of people on there on the internet that say we have to use Rust everywhere, and they're wrong. But yeah, I don't know. It's like if you're I call it like C++ 2, right? Like if you like C++, Rust is just like, in my mind, a better version of it. But I mean, of course, game devs will disagree because like you can't, the trade-offs that you have to make for Rust are like a little bit, it makes it hard to do some of the stuff that you would want to do if you didn't give a fuck about memory safety. Yeah, okay. What was I doing? Okay, so that fixes crashes with a little easy mutex lock, easy peasy. So we can get a cargo format. Cargo nightly format. There we go. Get diff. Nothing in here is crazy. It's just a mutex. Let's run our little linter, make sure that everything's good. And, oh, right. We banned unwraps. So let's look at that. Unwrap. Here it is. And we can just say expect poisoned lock. Normally, you would like maybe error check this in some way, but any time that you can like end up with a poison lock, I think that your program is so fucked that you might as well just hard crash, right? Because like, I think the only way that a block can become poisoned is if a thread who's holding the lock crashes and doesn't unlock it correctly, or something like that. And so it's just like, you've already crashed somewhere, you might as well just propagate the crash. Fuck it, you know? Does my linter pass now? Easy. Okay. So we can commit this and say, fix unsound multi-mute reference or something. I don't know. We'll fix it later. Okay. Let's jump into metadata stuff now. So the thing that I wanted to do was I wanted to be able to go into here, look at my items, and here I want to be able to like see like the name and the ID, so that when I'm like browsing by link, I should be able to like find the ID from this. And right now that's like impossible. So I think probably the first easiest piece would be add ID file to items. And then we'll add the name after, but the ID should be like an easy first step. So let's see. Let's see. Can you explain what is a kernel? I hear it a lot, but don't understand what it is. I guess it depends in which context you're talking. I've heard people talk about kernels in the context of like GPUs and like GPU programming, where they run like they call them like CUDA kernels or stuff like that, where you're basically running stuff on the GPU. I don't really understand why they use the word kernel there, but they do. But I think probably the more common one is like in operating systems, like Linux. Linux is like a kernel. and it's like the interface for your operating system for like interacting with hardware. So it provides like the base layer. I don't actually have like a strong definition. Like where a kernel ends and begins is probably a bit of like a gray area, I would guess. At least it's fuzzy in my head. But like you can think of it as like lowest level of operating system. Kind of, probably. Okay. What's the next? Adding file IDs. Okay, so we can look at the client. And we can look at like what are our directory listings. So in the item folder, I think that's this one, path purpose item relationships items. It's probably this one. When we list the directory for item, we can try to add a file that is an ID file. So right now, what do? We find names that come from relationships. Right, okay, so let's, that makes sense. So like if we are in a parent-child relationship, we're gonna list our parents and list our children. Cool, and then we link that on top of content here with, so we can just add a new thing. Here, well, this is laid out fucky wucky. Let's fix this. This should be like this, and then this comes down here. Okay. So we have one thing that's content, and we're just going to hard code in another thing, path purpose, and we're going to say the purpose of this thing is going to be to show the item ID. Okay. And we'll just call it ID. Okay. And now we have to like create that purpose. So we're going to say item ID, item ID. And these are getting like kind of unruly, all of these purposes. So we should probably put comments on them to like be more intentional about what they are. So this is root directory of entire file system. This is /bin or directory where we store binary executables for interacting with FS. Listing of all items by ID. This is a file for interacting, socket file that, oopsies, that allows sending, receiving messages out of band to the Fuse file system. Okay. Item is a metadata file that shows ID of current ticket or item. Okay, that's this one here. This is the directory associated with a given item ID. This is what? Item relationships. I actually don't know what this is right now. This is... I actually don't know what the fuck this is. Where is he created? When we have an item... Ah, I see. This is a folder showing all items associated with item ID by relationship ID. E.g., in a parent's children relationship, this is a parents or children directory. Okay. It's a good thing I'm doing this now, because if I came back to this later, I'd be like so fucking lost. This is a link to a specific item by ID, presented by name. Pass-through path is, so we have like files stored on the disk for a given item. This is like the files shown presented to us. So this is like content directory, essentially, or like a path that is passed through to the real file system, I guess. Filter is named filter that shows items filtered in some way unknown. Okay, there we go. Now I won't forget, hopefully, next time. And what we're doing, we're adding this like item ID file. So path purpose to file type, Item ID is going to go to file. Okay. And where else do we need to use this guy? When we list directory contents, if we tried to list directory contents of an item ID, we would say that's not a fucking directory, that's a file. So here we can say path purpose item ID goes to not a directory. And is that it? We are missing 322. We actually were supposed to put in the ID of the ticket here, so like this. I think we're chilling. So now, when we run the file system, we should see in test mount items 1, we have an ID file here now. And if we try to look at it, he says operation not permitted, which I think is just like negative. We return -1 on failure, so he's just saying like, nope. And it's because we have unhandled open for items I1 ID. Okay. So let's look at that. Unhandled open for. Right. Okay, so when we open files right now, we have two options. One is that we are trying, well, what is this saying? I'm actually confused. One is that it's passed through to like the normal file system. So like in like the content folder for a ticket, if I edit that file, we just call like the regular system open on like the translated path. Cool. But if otherwise, we try to call an actual open call. And this goes into our client. And here we assume that the only reason that somebody would want to open a file here is because they're using our like socket API that we added. But now we have to say, well, there's like this other thing that might happen where we might want a specific, how do I say this? Where we might be opening like some of our virtual metadata files. So I guess we can just say in here. Well, and he return we assume now that if we are opening a file, that we are creating a file ID that we're going to use for our socket API, right? So the idea is that like 3 people open our socket file and they send different messages. We want to make sure that we associate the right response with the right sender. So we kind of assume that there is a sender here, which is not necessarily true. Okay. And so we return none in the case where we are not a socket, and then when we, in the C API, we return -1. Maybe here we could just say that's not an error, the open would succeed, and any like reading and writing to the file would then no longer work. But I think that's not correct. I don't think that's what we want to do. I think that we want to, on open, return like some form of flag that says either we are a socket handle or we are like not, we have no work to do and that's okay, or we don't handle this type of input. Okay. Which means that we need some sort of like open handle. And here we can say socket handle that gives us like a U64 back for its ID. Or we say like metadata file or unknown or something. Or unhandled. That seems reasonable. Socket, we can call this socket. No op maybe. Like when on open, we either like allocate a socket number, or we do nothing, or we say, hey, this isn't something reasonable. And we can maybe call it open result. Sure. I don't like open result. open return, open ret. Sure, fuck it, whatever, it doesn't really matter. So here, we return open ret. And in this case, it's now, this isn't sum, this is open ret socket with this ID. This is open ret unhandled. And now we can say if the path purpose is item ID, now we can say turn, okay, open red, no op. Nothing to do here. Sure. That's reasonable, I guess. And then when we open here, we can say this was the case where we were a open red socket. This was now open ret unhandled. And now we have a new case, open ret noop. And in this case, we just return 0. Nothing is wrong. Sure. I don't know how much I like that, but it's not the end of the world. So now when I cat that same file, now we get no content, but nothing's failing, which is good. Yeah, that's great. So now we just need to handle, certainly, nobody's calling read, but we saw this before where Fuse is trying to be helpful for us. He's trying to say, hey, I'm asking someone I'm asking how big is the file? And if the file is 0 bytes long, then he doesn't even issue the read, but he should. So we need to say when somebody asks us how big we are, we need to give them like a sane answer. And so we need to, when we call here, when they call getAtter, they're going to like essentially do this. Stat, is stat a thing I can call? Test mount items. Hold on, I need to mount the file system. Cargo run. Test mount items 1 ID. And so this is going to tell me that the size is 0. And I think that we just have to report an accurate size here, I think. So we can say here, in the case where we're a file, we can just give us back the file size as well. Okay, and so that means that everybody who creates one of these things now has to flag the correct file size. So in the case of socket, we can leave the 0 file size, that's fine. So we can return file type file 0 here. But in the case of item ID, now we have to actually check what the content is. So if I say file type file 0 here, I think everything should still compile. Cool. And now we just have to like figure out what is the size of this file. So we can, you could go about this like a couple ways. You could like, how to say this? In order to get the size of the file, we actually have to generate the content. And so we could either say, I'm going to generate the content twice. Once when they check the what the size is, and once when they actually read the content. Or you could like cache it after you calculate it once. Caching it seems dangerous because in order to get the right answer, we have to like check the database in some cases, and I think that the database lookup should be cheap. So I think that we'll just say that like no matter what, for now, we're just going to calculate it every time. I guess there's no database access here, but I also just like generally in the other cases where we have metadata files, we will have to hit the database. So I just wanted to like think that through first. Okay, so we can say get item ID file contents, and we pass in item ID here, and he returns a string. Okay. Maybe he doesn't return a string. Maybe he returns a vector of bytes. And then we just say ID to string as 2vec. Encode UTF-8. How do I like turn this into like a bucket of bytes from a string? Rust string to U8. As bytes. is it 2? How do I get like a vector U8 out of this? Rust string to vector into bytes. That's what I want. Into bytes. There we go. Okay. Okay. Which means here I can say let content length is equal to get item ID file contents for ID, and get the length of that, and return the content length. So here, I guess we can just take this by reference. Doesn't really matter. And now, if I run the file system again, he's fucking broken, of course. So we have to go through all the places that use file and fix this. One more here. So here, I guess we're going to say the size. And we actually have to fill in the size here. So one of these size here is probably the one we want. st size is equal to size. And st size is a I64, so we can do try into expect file did not size did not fit in I64, which should like never fucking happen. So we'll just crash the program in that case. Okay, so when we look at test mount items 1 ID, we now get a size of 1, and if we look at like 11 ID, we should get a size of 2. Wonderful. So now we can try catting that thing again. And he'll say operation not permitted because we haven't implemented read for this guy, which should be pretty easy to bang out. So fuse client read. Okay. So we're kind of in the same spot here where we are checking if we are like a pass-through path, and if we are, we call the system calls for reading. If we're not, we call our read function. And so here we should probably oh, that's interesting. So we read assuming that we're a socket. So we could like maybe we should not do that. We have to pass in the path that we're reading from here as well, and that will determine what we should do. So in here, we take in Rust path as a path. Okay. I think everything should compile still. Great. And now here, we're going to have to switch behavior based off the path. We're going to say self.parse path. We're unwrapping for now because I don't want to deal with error handling right now. And we'll say parsed path is equal to this. And depending on the parse path, we're going to do something different on read. So in the case where it's a parse path purpose socket, we're going to continue to do what we did before, which is this. But everything else, we are going to return something. We're going to say like return error read error. I guess we'll say this is like not a socket. Not a socket. Not socket. Okay. Not socket. Or maybe not socket is the wrong term here. It's more like not unhandled path. Unhandled path, yeah. Cool. Unhandled path. And then, now we can handle our item ID file. And we can say item ID, or let content is equal to get item ID content file, get item ID file contents from ID. And then we just shove that in the buffer. So buff copy from slice content. Okay. 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 And then we return the length of the content. I guess we need to make sure that the buffer is large enough. Does copy from slice do that for us? Copies all elements from source into self using memcopy. The length of source must be the same as self. Okay, so what happens if it doesn't? If it will panic if the two slices have different lengths. Okay, so right now we're not really handling this like buffer input thing. I guess we'll just see what happens. We'll just see what happens. Cat test mount items ID. Oh, items 1 ID. Sick, we crash. What do we crash with? Slice, source slice length 1 does not match destination slice length 4096. Okay, reasonable. So we just now need to say let buff len is equal. I guess we do this 0 buff len like this. And nope, this way. Buff 0 buff content len copy from slice. There we go. There we go. So now that should work, I think. Okay, we got a 1 here. I would like to see a new line in it, I guess. So we can go back over here and we can do something like let ret is equal to this. Ret plus equals new line, and then return ret into bytes. And now, boom, easy. So we can cat test mount items 11 ID, and that says 11. 10 ID says 10, easy. And then we can go into our like test mount projects, image to text, and now we can see the ID of everything really quick and easy. That's sick. Perfect. Perfect. Cool, cool, cool. So I think that is a success. And now let's do the same treatment, but for the name of the ticket as well as its ID. And we can just, I guess, get status. We should run our lints. Make sure that everything's in a good state. I'll need a return. Fine. What like a? I don't know if I like that lint. Making me delete returns seems crazy to me. And then we have an unwrap that we didn't handle. So 278. So here we can just now say that our read error now, one of the things that it might fail at is parsing the path. So we can say parse path is from parse path error, and error failed to parse path. Easy. Easy. And then we just replace this unwrap with a question mark, and we're fucking chilling, probably. If we add that comma, boom, boom, all lints pass, great. So we can get add dash u, get diff stage, just to double check. What do we do here? Yeah, nothing crazy here. So we can say get add dash u, get commit. We can say what? We added file ID metadata file to item directory. And there's a bonus change in here, which is add comments for each path purpose. And fix me. I guess I'll just put this as whip here and say fix me. Fill in commit content. Okay. Cool. Now we are going to give the same treatment to metadata, or to the file to ticket name. Rust unwrap sounds like Swift's exclamation point, force unwrap. Is that like a... Yeah, what is... I've never programmed in Swift. Swift force unwrap. What does that do? Even though Swift doesn't show the conversion broke, you can see the code is safe, so you can force unwrap this. Swift will immediately unwrap, blah, blah, blah. But if you're wrongster, your code will crash. Yeah, pretty much the same. Same shit, same shit. Okay. So we have all the stuff piped around now for this to work okay. So now we can just say, we add another thing, item name, for the item ID, and we'll say metadata file that shows the name of current item. Easy. And we can just look at all the places where we use item ID. Ah, fuck. Item ID bracket. And we can just give it the same treatment. Same treatment. So this is item name, boom. And get item name file contents, which means that this guy needs an item name file contents, but he's going to need to look up the item name in the database. So here, what are we going to do? We're going to say like db get item by ID. Okay. So the item is this, and the item has like a name probably, sick, and then this is just let ret is equal to this, the item name. We're going to do the same thing where we append a new line to it before returning the thing into bytes. Cool, this gets dereferenced, and everything's chill. Everything is chill. Okay, cool. We're gonna have to fix this later, but we'll handle that in a second. This guy now needs the database to be passed down, which means that this guy needs the database passed in, which means that we can look for this guy here. He passes in self-db here, self-db here. Cool. Oh, fuck. This doesn't like that, which is not good. So list dir contents. Oh, mutability problems, the bane of our existence. Okay. So the path purpose is asking for the database to look up item names, but the iterator of directory contents takes self by immutable reference. So I guess here we can just copy all the shit out instead of like iterating, instead of holding on to a reference to ourselves and iterating over what we need. Because like this is going to read the database as well, in order to get the directory contents. We can then just say, I am going to collect you into a vector, which should free up the database for other shit. So we can just say into iter here. And I guess it's like this. Cool, I think that solves us for us. Make us allocate a vector, but that's okay. Client at rs244, he's missing... What's he bitching about? Parse path, self-db. Oh, I put this in the wrong spot. Oops. What did I do here? Jeez. Path purpose to file type, self-db. This should not be here. Okay. What happened here? What the fuck? Get diff. What did I do? What did I do? This used to say... Ah, we were supposed to be mapping the path. I see. I just fucked up everything. So this was like this. And then we passed in self-db here. And this wasn't here. There we go. There we go. Private check. We chilling? Yeah, okay. Now we're back to 319. Item type item name not covered. So that's just the same thing here, where if we try to list the directory of an item name, we go, that's not a fucking item name. Or that's not a directory, sorry. Okay. For a check. Alright, and we're chilling. We're chilling. Variant item name is never constructed. So when we create our directory, when we iterate the item directory, we do the same thing that we did here, where we add an item ID file, and we just add an item name file, and we'll just call it name, and we are chilling. Cool. Now we also, I guess we run it now, and we just see what happens. So we can cat test mount items 1. I guess we ls this folder first. We see a name file. Great. We try to cat it. We got operation not permitted because there's an unhandled open for items 1 name. Cool. So we can look for unhandled open for this. And I guess it's the same dealio where on open we get a no op. So we can just say that we do the same thing here that we did for the ID for the name. Easy. And then I guess we're going to have to handle the read as well, which is just the same thing as this. But this is get item name file contents. And we need to pass in self-db here as well. Boom, baby. That's sick. Okay. So now I think we can go through items by ID. One has item 2, ID 2, name Rust, name WASM, name SIMD. Yeah, this looks like it's working. Sick. Let's go, baby. Let's go. So now, if I press here, I can go back to by ID or by name. Sick. Sick. Happy with that. Okay, so now we've got kind of like the system to handle metadata files, and it's pretty easy to like hack ones in. So now we can start looking at like the relationship stuff as well. After our lints pass, I guess. Certainly we left an unwrap in there. We did at 179. So this guy probably needs to return I guess this will return an option evacuate. So if the item ID doesn't exist, then we won't return shit. And everybody who uses this guy now needs to check. So he can just unwrap or 0 here. So basically anytime, sorry, we need to map this guy to x.len. And if he doesn't exist, we'll say that the content length is 0. Actually, I don't like this. Instead of returning an option thing here, we'll just return an empty vector in this case. And then everything else should just work. So, is that what I want to do? I guess if the item ID is invalid, we should actually, like, fail. We shouldn't say, like, here is the value. Fuck it, whatever, it's fine. It's fine. Let item is equal to, this is going to say sum here. Else we return an empty vector. Like this. Default. Cool. And now if we lint, everybody's chilling if I format correctly. Hopefully that's the last lint that fails. Boom. Okay, easy. Whip. And we'll call this add name file to items. Okay. So the next thing I wanted to do was I wanted to find a way to like identify relationships. So in the same way where we have this like items folder where we now have metadata associated with each item directly in here, I want like a relationships folder that does the same shit. But in here we're gonna have like, instead of ID name, we're gonna have like from name, ID, from name, and to name. I think probably makes sense. Let's think about this. If I look at an item and I look at his item by ID, do I want to see like the relationship folders in here? No, it's fine. We'll just start by putting the relationships folder up at the top, and then we'll figure it out from there. So therefore, it looks kind of like you're building a tree UI over a graph dataset. It does, yeah. That is kind of what I'm looking for. But a more important, like, the distinction is like a tree UI that also lets me quickly edit the contents inside it with my normal text editor. But yeah, it is. We're just using the file system as like basically a visualization for our database. But yeah, I agree. Okay, so let's add a relationships folder. So here we can say relationships, which is a listing of all relationships by ID. And that's going to be a directory. And when we try to list the contents of that directory, we are going to do something similar that we were doing for items, but for relationships, we're going to say get relationships, and this is going to say get relationships error, and then we say this thing is going to be a relationship with the given ID, and its name is going to be that ID as a string. Okay, all that seems reasonable, which means that we need to have a relationship directory associated with a given relationship. He's going to have relationship ID like this. Easy. And we have to add the error type for get relationships. So we're going to say fail to get relationships. Get relationships. And this is going to be get relationships error. Does that not exist? What is like the error type on the DB? Get relationships. Query error. Cool. Alrighty. Failed to get relationships. Do we compile? We do not compile, because we now have to add all of those cases. We need to handle a path type of relationship as well. So that's just going to be a directory. Is that it? Nope, there's more at 337. And path purpose relationship with relationship ID. He is going to have to create some iterator, but for now we'll just let him be empty. So we should end up with a relationship directory with no contents, I believe, if we do this right. Except we haven't actually added the relationships to the root of the file system yet. So here, we have items, and now we just want relationships, which is like this. Cargo run, and now we should have a relationships directory where we have two relationships, which is correct for our database. And now we just need to put the content in here. Cool. Cool. Everything is coming together quick, which feels good. So in a relationship, we are going to say, I want that relationship, self.db get relationship, and we pass in the relationship ID. For now, we unwrap because I don't want to think about it. And we're going to add metadata files for the like source and destination name. So we'll say, well, what's in this guy right now? He is from name, to name, and ID. Okay, cool. So we can say let. I guess we just say that we have hard-coded, no matter what, 2 files: path, purpose, relationship from name for this given ID. And his thing is going to be called from name. Okay. And we do the same thing with 2. Okay. Easy. And we'll say from name and to name here, which means that we actually have to handle these guys. And we have to say that they are going to be files, relationship from name, and relationship to name. And we'll just say this is unimplemented for now because I don't want to think about it yet. Okay. Where else is this used? Directory listing. If we are going to say that we're not a directory in these cases, so we have relationship from name and relationship to name. These are now not directories, so they can't be listed. And 383, we forgot some like 2 strings on these guys. They had to go from string references to own strings, and everything is move in. Sick. How is it possible to develop in Rust? Shouldn't it be a Linux kernel member module? Enlighten me, someone. I'm new to this. Okay. So, one, even if it was a Linux kernel module, we could develop that in Rust because Linux has recently added Rust support, I think. I don't know if it's experimental, but they do have Rust in there. But either way, what we are doing is we're using this library called libfuse that basically exposes a user space API for creating file systems. So I think that there's probably a Linux kernel module associated with it. I actually don't know. Fuse kernel module. I would assume that, oh, we can actually probably check. Hey, yeah, let's do that. If we do strace, if we run strace on, oh, hold on, cargo run. Let's run strace on our thing. Target, debug, to do fs. That will probably give us a clue if they're opening some handle into the kernel. Fuse. They're calling into libfuse. lsmod grep fuse, not a bad idea. Yeah, okay. So there is like a kernel module that is associated with Fuse, and probably if you're looking like the dev stuff, there's a file in devices that says, hey, this is how you interact with Fuse. And so then what that allows us to do is that allows us to implement a file system using this interface. So the Linux kernel goes, do you got, well, I guess we ask it, we say, hey, Linux kernel, I'm putting a file system here. And I call these functions in my program when somebody tries to access those. Yeah. So then libfuse is like a C library, and so we've implemented like bindings to libfuse that we are using from within Rust. Yeah. Okay. So I think we're kind of chilling here, actually. So we should now have from name and to name files. Nope. Oh no, we're chilling, yeah. So we should have from name and to name files in our given relationships. Except he crashes, which is kind of sick. Not implemented, right, because we just didn't implement those files. Fuck. So that was here on path purpose. These guys were going to be files, and maybe for now we'll stub them out with 0 length instead of crashing. And maybe that will give us something to look at. So now we should go to test mount relationships 1 from name, to name, but they're both empty. Great, which means that now we just have to implement those same metadata like getters. So unhandled path. Let's go back to, well, mount. I can't remember where all the things are already, so we can say cat test mount relationships. Nope, test mount. Ls. Oh, I'm in test mount. That's why. Cat test mount relationships 1 from name. Operation not permitted. So we have to handle unhandled open right. Unhandled open for this. Which means that in open, we need to flag these relationship stuff as no ops for open, path, purpose, relationship to name, and path, purpose, relationship from name. Okay. And then on read, we're going to have to do something as well. So read, we're going to say item name, this is relationship from name is going to call get relationship from name file contents. And we're going to do the same thing for relationship to name. This is going to say to name. We will just implement something similar here. So get relationship from name file contents. This is going to take in a relationship ID here. And we have the same thing with to name contents. We looked the thing up in the database. So we get the relationship for this ID. Where I guess we'll do the same thing here, where if it's empty, we return nothing. So this is get relationship from this relationship ID. Then, oh, this is a failable thing. Okay. Option sum. Ugh, so this can fail. We'll throw some unwraps on it for now, because I don't want to think about it. So we throw just like a double unwrap on here. And we'll say the relationship is this thing. And relationship from name. Let mute ret is equal to this. We add a new line. And ret into bytes. And we're starting to see some sort of pattern emerge here that we might want to think about. So we can say like function with new line s string like this. And this is just going to take a thing and return s plus equals \n, return s. And maybe we can say we don't just want with new line. We want a with new line as vec. So this is going to take in a thing. We're going to add a new line and say s into bytes on here. And then everyone here can just say with new line as vec. Like this. With new line as vec item name. With new line as vec relationship from name. There we go. And now we just do the same thing, but with to name. Cool. Cool. So now we get the content length by saying get item, get relationship from name. This is to name, content length, content length. Okay, easy. And are we chilling? Is everything else there done? Looks like it might be. Looks like it might be. So we can look at test mount, relationships 1, parents, children, blocked by blocks. Sick. Cool, cool, cool. So it looks like that's working. We have like, now we have like a way to tie back like what I think of a relationship as in like parent-children relationships, and I can now get the ID for that. Which means that when I create an item, I should be able to say, I want to create this item, and I want to add this relationship that has this ID, which is pretty sick. Which means that now we should be able to add a way to create relationships. Well, I guess first we need to commit this. We need to commit this. Which means that we have to fix the errors and shit that are associated with it. So, cargo format. Run the linter again. We've got a lot of unwraps kicking around that we don't want. So here, I guess we're going to say we have a result, and he can be a query error, if I remember correctly. Okay. Which means that we should now just be able to replace the first layer of unwraps with the question mark. Okay. And we have to write okay here, and okay here. And the people who use this guy now need to throw a question mark on him, I guess. And I guess we have to map the error, so path purpose to file type returns IO error, which is now no longer the right type of error. It now is like a possible, there are a couple errors that it could be. So we now need to say like path purpose to file type error. And one of these things that it could be is IO from SCD IO error. And another one could be query. And we put names on these, say like IO error, query error. I guess technically calling these things both query errors, calling them IO and query doesn't really like flag what the actual intent was. So here we should call them more like this should be pass through get metadata error. So let's say failed to get metadata for pass through file, and we'll instead of writing from here, we'll write source, because I don't want to cast all IO errors to this thing, just the ones that I care about. And then here we don't have like general query errors. We have get from relationship from name and relationship to name. And so this is going to say failed to get from name for relationship, and this is going to say failed to get to name. Okay. And this should say source, not from, as well. Okay, which means now, where we had this IO error, now we can return a path purpose to file type error. We need to map all of these errors, so map error path purpose to file type error from name. And this is now going to be to name. And down here, we're going to say map error path purpose file type error get metadata. Is everyone chilling? I got the bracket in the wrong spot here. Fix. Cargo check. Why? Why? Type mismatch 584. Because this guy is no longer an IO error. He is a path purpose to file type error. This guy doesn't like that for some reason. What the fuck? Path purpose found to ensure. Oh, because this guy was an IO error. This is now also a path purpose to file type error now. What a pain in my ass. What a pain in my ass. No method length on result. So here, we need to put some question marks on these guys. I guess we'll put unwraps here for now, just to try to like squash the compiler errors. Okay, that compiles. And now on read here, we can fail because we can say fail to get from name or the to name due to query errors. Okay, so we can say error failed to get from name for relationship. And this is a... I guess this is just going to be the same errors as these. Okay, so map error, read error, relationship from name, question mark. Map error, read error, relationship to name, question mark. Holy hell. All right. We format. And we lint. Are we chilling now? Please tell me we're chilling. Fuck, there's more. We are now have like an option as well there because they might not exist. And so I guess in the option case, we'll just return an empty file because I don't want to deal with it. So we're going to do the same trick where we say, let some relationship is equal to this thing. Otherwise, we return default. And the same thing goes here. Else, return default, default. Lint. Come on, baby. Oops. Fuck. We need to write okay here because it's a fucking error type. Okay. Okay. And now it looks like our linter is probably going to pass. Nice. And does it still fucking work? Did I break anything along the way here? Nope. Looks like everything is chilling still. Get status. Get add -u. Get diff staged. Anything fucked in here? Change some error types. Error type changes. Error handling. Adding the relationships folder, as well as each relationship, it's from name and to name. Some refactoring to get to squash some of this stuff down. Otherwise, we are just adding handlers for each of these guys. Nothing crazy. Whip, relationship metadata. All right. All right. So this is done. Add way to create relationships. Hello, can you recommend a good first project to do in Rust? I cannot. I always find this hard because I think that like if you're like, how do I like give me something to do? It's like, it's hard because there's like an infinite number of things to do, and like the goal for me is always I want to make something, and so I'm going to find a way to make that. But I guess the goal is kind of inverted here, where your goal is probably you want to learn Rust, and so you need an excuse to do so. And so I think it's hard for me to think of like what would you be interested in. It seems like kind of personal to me. There's like lots of like, yeah, I don't know. I like you could always just like hit up some like leet code problems and just try programming those in Rust if you just want to get familiar with the language. But in terms of like a project, it's like, I don't know. I think that's personal. Personally, I think it's personal. But you could always, if you're just trying to get familiar with the language, you could hit up like, what's it called? Code in game or something. Just like one of those like online, here's a general problem and try to like bang them out in Rust. I don't know. Okay, let's see. Now we need to add a way to create relationships. So we have this binary, create item. And this guy is a like executable that's bundled with the operating system. Create item here. And if you call this, then he'll like automatically do the stuff that's like negotiate, like looking up the socket to talk to the file system and send the correct API over. And so we need to add one now that's like, I'm going to create a relationship. And so the create item one, what he does, if I say like create item, this, he's going to say, I created a new item and here is where he is. So if I go and look at items 12 and look at his name, which I can do now, which is pretty sick. I couldn't do that like earlier today. He has the name that I just gave him. And so now I want to do the same thing, but for a relationship. And so the idea is that like I'd be able to make a script that says like, I want to make this ticket and he's going to be part of this project. So first I have to create the ticket. Then I need to add a parent-child relationship to him for the given project. So what does that mean? First, I need to add like a create. I guess I already have the relationships I care about. So I guess it's actually going to be this order. I'm going to start by trying to find a way to create relationship links. And then maybe then if I have more relationships I want to add, I'll add that after. So what? We're going to go. This is going to be similar. We're going to edit source bin create relationship. And this guy, instead of... No, fuck. This isn't create relationship. This is create relationship link. Create relationship, or create item relationship. I think that's the nomenclature we've been using. So the idea here is we want to add a relationship to an item. Okay. So what are my arguments here going to be? They're going to be like relationship ID, item ID. Okay. And I guess we're going to call this like from ID and to ID. So this is going to say for relationship parent-child, I'm going to add a link between my between like the parent and the child. Okay. We are going to have to parse these arguments in some way. And the way I usually do this is I get an iterator of strings and I pass them in to my parse function like this, and I return an arg structure. Now, in the case where somebody passes in help, I'm going to print out the how to use this thing. And I also like to take in the program name here as a str, I guess. And here we say std process exit 1 if somebody calls help. And then we say print line. And what's like the ls help? What does this normally look like? Usage, program name thing, and then arguments. Yep, okay. So we have usage, program name, relationship, program name, args, like this. And args are relationship ID, from, and we'll call this relationship ID, like this, item ID, and to, also an item ID. Okay. And for now, we'll just call help with let program name is equal to the first argument. And if the first argument doesn't exist, then we give our own program name, which is going to be create item relationship. Okay. And we have to do this. Okay. Okay. Almost there. You take. And now we can say let args equal to args parse. And we say std env args as our input here. All this stuff gets commented out. And cargo run bin, and this should be create item relationship. So he doesn't compile because we didn't pass in the program name here. We forgot. And there we go. We're chilling, except for the fact that these look better if we do this. Add some new lines manually. Cool. Okay. So now what are we trying to do? We are now trying to actually parse the arguments. So we can say, well, let sum arg is equal to it next. Match arg, I think it's as ref, is how we get them to be strings non-consumed. And we just have relationship from name and to name. So, and then we need to pass the IDs around. So we have the relationship ID is equal to none. We kind of like flag these guys as unset initially. And then at the end here, we can say, if we didn't get them, well, let's actually like assign them first. So if we get relationship, then the relationship ID is equal to sum next argument. From name is equal to sum next, and same with to. Okay. And anything else is going to return an error. I guess we can just panic here. Since this is like a short running executable, just anything that doesn't work, if we just like fucking crash, I think that that's fine. So we can say unhandled argument. And maybe we even pass in what it is. Cool. So here, we need to cast these things. So we can say parse. I guess we say map like this. Type must be known at this point, so I guess I have to specify U64. There we go. Nice. And I'm going to copy paste this a couple times. So this is from ID to ID. We can say let relationship ID is equal to relationship ID expect no relationship ID provided. And give the same treatment from ID and to ID. And then we can just return the thing. I guess we also have to handle -- help. This guy should show self help with the program name. Easy. Easy. Ah, fuck. I don't really want to expect here because I want to show the help after. On all of these guys. So I actually do kind of want an error type here. Arg parse error. And we derive error and debug. And we say no relationship provided. No from ID provided. No to ID provided. Parse relationship ID, parse from ID, parse to ID. What a pain in my ass. Okay. So if there's no argument here, that's fine. When we unwrap this guy, how do we want to handle this? This guy is a result of arguments or arg parse error. And if we fail to parse, we print the failure. So I guess we have to say match all of this. And if it's okay, we propagate args. Okay. And if it's not okay, we say print line E, and then we print help. And we're missing the program name. Ugh, what's like the quickest, like, what's the easiest way to fucking organize this, man? This guy always returns args. Okay. Then we put all of this shit in a lambda. Sorry, closure in this language. Closure in this language. And if we say match this thing, let air res equal this, match res, and if it is okay, we return okay this. If it's an error, we do this print here. Oh my god. Hopefully this makes sense. Hopefully that works. Okay. Then we can call this again as let args equal to args parse. Oh my lord. Okay. Then here we return args with relationship ID, from ID, and to ID. And then we just have to map all of our error types. So these come from stood num parse int error, probably. Which means that here we can say if there's no relationship ID, it's okay, or args parse error, no relationship ID provided. And then if that's failed, we have a parse relationship ID failure. And now we give the same treatment to both of these guys. So this is from ID, no from ID provided, parse from ID. And this is to ID, no to ID provided, parse to ID. Okay, thank God. Now, what is it bitching about? If you meant to create this closure and immediately call it, surround it with parentheses, that's crazy. I didn't know that you could do that. IRC lambda is to closure as class is to object or function stack frame. Oh, interesting. I always just thought they were interchangeable. But that explains why people care. Okay, so we should be able to now run this guy. And, oh, he actually doesn't compile because I need to use this error. And I need to say all of the error types here. So error, no relationship provided. No from ID provided. No to ID I provided. Failed to parse relationship ID. Failed to parse from ID. Failed to parse to ID. God. And for some reason here, the fucking error doesn't resolve correctly, so we have to say result args parse args error. Arg parse error, like this. There we go. Jesus. Okay. So that compiles, and he says no relationship provided, so then I say relation relationship 1. No from ID provided, great. From 1, no unhandled argument from. So this is from, that didn't handle that quickly. So we're going to say unhandled arg with the string of what the argument was. We're going to say error unhandled argument with this name. Okay. And here, instead of panicking, we say return error arg parse error unhandled argument s to string. Okay. Unhandled argument from. So I put names here for some reason, which is just not true. From 1, no 2 ID provided, 2, 2. Okay, so that works as expected, and now we just have to actually do the thing. So instead of creating an item, we're going to create an item relationship. Relationship O. And this is going to create item relationship request, which is going to look a lot like this, except it's going to be create item relationship request, which has a relationship ID and a from ID and a to ID, which are both item IDs. Which means that we need to import item ID and relationship ID. Boom. I don't know what the create item relationship response is going to look like. Maybe just nothing? So maybe we just don't read back a response at all. That seems fine, because we don't have anything to display. And so we just won't read anything back. Okay. Relationship ID, I guess we'll serialize these as U64s. Okay. And then when we're in our executable, we're trying to create an item relationship. We say create item relationship request. And this is just going to be relationship. I guess what's kind of nifty here is we don't actually have to make this a args parse error. We don't have to do this as args here. We could just directly construct the relationship. So let's do that. We're going to say, well, this is our, sorry, the request. Create item relationship request. Okay. So here we're going to say parse args. No more args. We're going to say just parse args. And this is going to be a request. Request, and then we shove the request in here. Like this. And now we just remove this like self-help. This is just now a free function help. I think everything else actually just kind of like works. Card check. Almost. 338 in, in client. Right, we actually have to handle the thing. So if somebody asks to create a relationship, item relationship, what are they going to do? What are they going to do? I guess we are going to call into the database, create, add item relationship, we're going to call it. And we're going to pass in the rec from ID, rec to ID, and the relationship ID. And we're going to have to cast these into their appropriate types. Item ID, item ID, relationship ID, like this. Boom. Okay. Now this can fail, I guess. So for now, we're just going to type wrap here because I don't want to deal with it. And what now? Expected I64 found U64, so that's easy. We can just change all these to I's. And now we have an issue where people are trying to return args, and this should be create item relationship request. And we have some U64s around, so these should be I64. And we compile. Okay, so we have our requests, and we can send a client request. And this is kind of expecting that there is always a response. Which I guess maybe makes sense. I guess. Maybe, fuck. What do we want to do here? I guess we'll just we'll just send a, like, empty response or something. That's annoying. That's annoying. Actually, I guess for now we'll just let it fail. And, we'll just see what happens. Because I just want to see if at least this works. Oh, the other piece here is in our client. We need to provide this binary. So somewhere in our tool bins, we pass in this like create item thing. And we'll just do the same for create item relationship. Okay, that should be enough. So to do fs. And what doesn't he like? 533. Pass through path. Oh, oops. This is create item path, like this. And this is create item relationship. Create item relationship path is like this. Okay. Chilling, 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 chilling. So now we should be able to go test mount, bin, create item relationship. Relationship 1 from 1 to 2. I guess we actually want to test this. So we're going to go to items. We want to like look at like items 11. And let's say we want to add a parent to 11. So we'll do the same thing, but we'll say to 11. And now if we go to items 11, we're fucked. That doesn't do what I wanted. In fact, it made a new item. Why did it do that? Why did it do that? Did I fuck this up? Create item relationship request. Request is a create item relationship request. API. That's here. And he's supposed to add item relationship. So what's the problem? Adding item relationship. Let's see if that is running at all. Create item relationship. Create item relationship. So does he say create item relationship? Creating... No. So what the fuck is the problem there? There's a bug somewhere. Why is this not happening? Why is this not happening? Send API request. Send client request. We serialize request. Well, that's actually not... This is supposed to be crashing, is it not? What the fuck? We're gonna mount the file system again. ls cd.ls. These are different files. And if we look at target, debug, create, item, star, do these hashes match? Yes. Okay. Am I high? Create item relationship. This is running send client request with create item relationship. Okay. We are not failing anyway, and we're not even failing to read the response, which is surprising. Maybe we'll print out the response here just to see. Print line. Like, what the fuck does it think it's doing? Response. Cargo build. Cargo run. CD dot. Create item relationship. Oh! It probably just didn't recompile the binary. Okay, but we think that we should have added a relationship 11, and he does have a parent now. Okay. So it's working. And now we just have to say, we just have to add the, like, response, I guess. So can we just say, like, client response null? And we'll just send a null response in that case. So here we can say Serde. We just do the same thing that we did here. Except we need to create the response. So the response is equal to client response null. Okay. So does that still fuck up? Connection aborted because unwrap error. Oh, because the fucking thing already existed. We can't add a duplicate fucking item relationship. Okay, sure. Sure. That's reasonable. Let's try again. So we are going to run test mount bin create item relationship 2 from 11 to 1. Unknown variant null expected create item. So that's at Fuse API 45. This failed? Why? Expected create item. I guess we can't just send a nothing response. I guess we have to send something. Oh, what a pain in my ass. Ugh. Fuck. I guess we'll just, here's what we'll do. We'll undo that null shit. We'll just send no response. Okay. And in our API, we'll just check if we expect a response here. So when we send the client request, we'll say, this is an optional client response. Okay. And we're going to say, depending on the client request, if we are a create item request, we are going to expect response. Otherwise, I guess we're gonna say if we are a create item relationship request, we're gonna just return none here. And otherwise, we do nothing. And expect a response. Yes. Which means that in create item, we now need to expect some this. Else panic unexpected response. And now we shouldn't crash in the other case. Because when we create the relationship, we don't expect a response. So there's nothing to do here. Cool. Cargo build, everything. Build the world. Cargo run. And so now we can say, what happens if we try to test mount bin create item, and we just give it the name test, okay, at items 13, and then we say test mount bin create item relationship from ID 1 to ID 13 relationship 1. He doesn't like these IDs, so it should be from and to. What's he bitching about? On-hail argument 13. Oh, oopsies. From 1 to 13 relationship 1. No crash. And now we should have a thing, test mount, items 13, that has a parent image to text, which has ID 1. Hell yeah, baby. Okay. Okay. I think we're kind of chilling there. So I think that gives me everything I need to actually, like, work with this the way I want to. So I think I'm going to call it there. That gives me everything I need. So thanks for watching. If you like what you saw, I stream most days at around 1 or 2 o'clock Pacific time for around 1 or 2 hours. If you want to catch up, there is a YouTube link in the Twitch description where the VODs go up. And if you're watching on YouTube and you want to swing by, say hi, there should be a Twitch link in the YouTube description. GitHub and Discords are also linked in the Twitch description, which this code will eventually end up on GitHub, and the Discord is there for if you want to like chat about shit while we're offline. Otherwise, thanks for watching. Catch you on the next one. Bye.